Alright, so today, Friday, obviously I'm a little sick. So we're gonna have a pretty chill day today. Estoy un poco enfermo desde el miércoles, ¿verdad? Pero hoy me sentí un poco peor. Pensé que no iba a poder venir hoy, pero acá estoy. Alright, entonces hoy va a ser un día regular, día relax. Right, nomás vamos a ver 2 videos en YouTube y vamos a sacar notas. Alright, so pretty easy day today. Just gonna watch a couple YouTube videos and we're gonna take notes. Alright, more specifically, I want you guys to write 3 things in the video that you learned. Alright, so there's 2 videos. One of them is going to be talking about the Yellowstone volcano. Alright, 2 videos. El primero va a ser hablando del volcán en Yellowstone, que está en Wyoming. Alright, second video is talking about all the nuclear waste that we have in the world and why it's bad. El segundo video es hablando de toda la basura nuclear que tenemos en el mundo y por qué es algo malo. Alright, so 3 cosas que encuentren interesantes, importantes del video. 2.
Report to the main office, main office.
2 palabras que quieren aprender más. 2 palabras que encuentran interesantes y que quieren aprender más palabras. So also we're doing 3 important things that you guys learned from the video. 2 words that you want to learn more about. And then 2 words that are chemistry related. Alright, Alice? 2 words that are chemistry related. Alright? Y 2 palabras que están asociadas con esta clase de química. Alright? Vamos a estar hablando de volcanes, de plantas de nuclear. Entonces, va a haber muchas palabras que ya nosotros sobre el semestre hemos aprendido. Alright? Once we're done with that, we're going to have a discussion. Alright? So we're learning, so we want to know what can happen if a volcano like Yellowstone erupts, or just any volcano in general, alright? Queremos saber qué pasa si un volcán como Yellowstone erupta, alright? O volcanes en regular. Y también queremos saber por qué teniendo basura nuclear es malo para el planeta. We also want to learn why nuclear waste is bad, alright? Alright, so we're going to play these videos real quick. Just please pay attention and make sure you're writing down. I need 3 interesting things, 3 cosas interesantes, 2 words that you want to learn more about, 2 palabras que quieren saber más sobre ellas, y también 2 palabras que son asociadas con esta clase de química. And then 2 words that are related to this chemistry class. Yes, Angel.
No hay límite de...
No. So good question. So when you're gonna take your notes, you can write as many notes as you guys want. All right. Cuando van a tomar las notas pueden escribir las notas que quieran. All right.
Sí, pero son más a partir de cuántas se considera. Bueno.
Sí, pero acuérdense, lo importante es 3 cosas interesantes, 2 palabras que quieren aprender más sobre ellas y 2 cosas que son asociadas con química. Yes. Yes, pencil. All right. So we're gonna play this video. Please pay attention. No phones out, please. Huh? Yeah.
Alright, brilliant. Learn to think like a scientist for 20% off by being one of the first 500 people to sign up at the link in the description. Nuclear energy is one of the cleanest, most efficient, and most available sources of power on Earth. To generate 1 kilowatt hour of energy, the amount that an American household consumes in 48 minutes, nuclear power plants only emit 12 grams of carbon dioxide, enough to fill about 32 liter soda bottles. Meanwhile, to produce the same amount of energy, coal plants emit 820 grams of CO2, about a full bathtub full. Factoring in the environmental cost of production, nuclear energy is cleaner than hydropower, than geothermal, than solar, than really any energy source except wind. But that doesn't necessarily mean nuclear is the long-term solution for the world, because nuclear material is perhaps the most poisonous substance on Earth. 2 times in history have nuclear power plants leaked significant amounts of radiation. In 1986 in Chernobyl, Ukraine, and in 2011 in Fukushima, Japan. 31 people died in Chernobyl, with at least a further 4,000 expected to contract early lethal cancer due to radiation. Fukushima was better contained, with only 2 deaths, both unrelated to radiation, and only 130 early cancer deaths expected. But, additionally, each site still today has massive exclusion zones where humans cannot live due to ongoing radiation. Hundreds of thousands of people were displaced from their homes and will never be allowed to return. The economic damage of Chernobyl is estimated at nearly $250 billion, significantly more than the GDP of Ukraine. The Fukushima disaster, meanwhile, taking place in a much more populated and developed area, is expected to set Japan back over $500 billion, almost 10% of their GDP. In addition, uranium, the element most commonly used in nuclear reactors, is not in limitless supply. Using present-day extraction methods, there's only about a 230-year supply of uranium left. Many would say nuclear is only a short-term solution to reduce carbon emissions until truly sustainable energy can become commonplace. But the biggest problem with nuclear energy is not the risk of meltdown, it's not the supply of uranium, it's this: nuclear waste. All current commercial nuclear power plants work through the process of nuclear fission. As a radioactive element decays, the individual atoms split into 2, but when that happens, the reaction also releases energy. There are plenty of different designs of nuclear reactors, but in general they capture the released energy by using it to heat up water into steam, which runs through turbines that spin generators. The nuclear element used is typically uranium, which, after about 6 to 8 years of usage in a nuclear power plant, will have released enough of its energy that it is no longer useful in nuclear reactors. But that doesn't mean it's done emitting energy. The fuel rods will remain radioactive enough to emit a lethal dose for tens or hundreds of thousands of years past their removal. So the question is, what do you do with them? The answer is simple: put them somewhere where they can stay, undisturbed, isolated, forever. But that's not all that easy. In fact, no nuclear waste worldwide is currently in what is considered long-term storage. Every bit of nuclear waste in existence is in temporary storage facilities to be used until a long-term solution is built. Most of that nuclear waste is stored in
Every leap forward starts with asking, can we use genetics to fight cancer?
in pools of water. Water does a decently good job of shielding radiation, so this is an inexpensive and easy way of storing the rods. Usually, these pools are physically inside the nuclear power plants, so when spent fuel is removed from the reactor, it's put directly into the water and left there. The radioactive material, since it's still emitting energy, continues to heat up the water, but cooling systems and pumps keep the water below boiling temperature. But to do that, the plant needs power. If the power fails and the backup generators fail, the pumps and cooling systems stop working. So the water heats up and can boil off. The water is what blocks the radiation, so without water, the radiation just goes right out into the environment. In fact, exactly that happened at Fukushima. Both the primary and backup power sources failed, so the pumps and cooling systems for the spent fuel pools couldn't run, leaving the water to heat up. The situation was brought under control before enough water had boiled off to release significant amounts of radiation into the environment, but had it not been, thousands could have been killed. Once nuclear waste has cooled down in storage pools for 10 to 20 years, it typically is encased in casks. These concrete and steel containers block in radiation, but this solution is far from permanent. It does not consider earthquakes, it cannot withstand tsunamis, and it would not work without humans. These casks require security and they require maintenance. Without humans, they could easily be damaged or breached over time and release radiation into the environment. Modern humans have only existed for about 200,000 years, so one can hardly be sure that the species will survive for the millions of years that the toxic nuclear waste will continue to emit radiation. What's more, one can hardly expect that the dominant civilizations that have nuclear technology today will continue to exist for even thousands of years. The Roman Empire was once, without a doubt, the most powerful civilization on Earth. Scholars even believe that it is the most powerful civilization to have ever existed on Earth. More powerful than the US, than Europe, than any modern civilization. But it fell, and so too will the West. Therefore, long-term nuclear waste storage needs to last longer than any political structure, it needs to work without the supervision of humans, it needs to be truly and unequivocally permanent. Finland is building just that. This region is largely devoid of natural disasters. It doesn't have earthquakes, it doesn't see tsunamis, it really doesn't encounter any natural
Ok, por ustedes que hablan español, por ahorita, ¿qué le entienden al video?
Sobre cómo se produce la energía.
Energía.
¿Y cuántos años tarda
Ok.
la
Ok.
energía?
¿Ustedes qué?
Igual. No,
Ok.
pero-
Pues es obvio que las plantas nucleares son peligrosas, ¿verdad? Pero es mucha energía que nosotros usamos. Entonces, como, no sé cómo decirle, como las pastillas, ¿verdad? Las pastillas, pues a la gente toma pastilla para que estén bien. Pero las pastillas poco a poco están matando, ¿verdad? Es cosas que necesitamos, pero que, como un carro, ¿verdad?
¿Lo podemos
Todo.
hablar en español, no?
Sí, pero trata de ponerlo en inglés también, ¿verdad? Como los carros, ¿verdad? Ahorita hay muchas pláticas de la polución de carros y todo eso, ¿verdad? Que es malo, pero pues ¿cómo vamos a llegar al trabajo? Ni modo que caminando, ni a bike, ¿verdad?
Es como ya ahorita con los carros eléctricos.
Ajá, por eso hay mucha gente que no haciendo carros eléctricos. ¿Ok?
phenomenon that could damage a nuclear waste storage site, especially if it's 1,500 feet underground. Beneath an island on the Finnish Baltic Sea coast, the country is digging. They're building the very first permanent nuclear waste storage facility in the world in the stable bedrock 1,500 feet below. Currently, they're just finishing their dig down. Then very soon, in 2020, they'll start filling the facility with nuclear waste. They'll dig long tunnels with small holes in which they'll place casks of nuclear waste and backfill the tunnels with clay to be left for an eternity. With this system, there's near zero risk of nuclear material leaking out into the groundwater, and once it's filled in the year 2120, it can just be left forever. Because the material will be so far down and so difficult to get to, no human management will be necessary once completed. No security, no maintenance, nothing, which means it should be truly secure. But before leaving it, they do need to fight against one thing: human nature. As curious beings, it's hard to combat a person's urge of discovery. If someone finds a mysterious structure from thousands of years ago, it'd just be natural to want to open it up. And that's a problem for nuclear waste sites. We essentially did just that with the pyramids in Egypt. These structures were built as the final permanent resting places for the elites of Egypt, and we opened them up because we were curious. Opening the nuclear storage facilities would release radiation into a future civilization, so we have to tell them to leave the sites alone. But that's easier said than done. The US Department of Energy commissioned a study on how to communicate the danger into the far future. The key is to create a message that conveys how uninteresting, how unimportant, and how dangerous nuclear waste is. They settled on the following text. Sending this message was important to us. We considered ourselves to be a powerful culture. This place is not a place of honor. No highly esteemed deed is commemorated here. Nothing valued is here. What is here was dangerous and repulsive to us. This message is a warning about danger. The danger is in a particular location. It increases towards the center. The center of danger is here, of a particular size and shape, and below us. The danger is still present in your time as it was in ours. The danger is to the body, and it can kill. The form of the danger is an emanation of energy. The danger is unleashed only if you substantially disturb this place physically. This place is best shunned and left uninhabited. The idea would be to translate a message like this into every United Nations language: Arabic, Chinese.
Entonces, trabajan por los United Nations, mandaron un mensaje que dice que, o sea, cuando uno está trabajando con algo que se trata de nuclear, es bien peligroso, ¿verdad? Y si algún día hay una planta, una fábrica con cosas nucleares, pues si hay un terremoto o un tsunami, lo que sea, pues puede ser un desastre bien grande, porque como vemos en nuestros elementos, ¿verdad? Lo nuclear se dispersa, ¿verdad? Entonces, lo que puede pasar si pasa algo, un terremoto, un tsunami, lo que sea. Todo eso se va a ir para el aire, ¿verdad? Entonces lo que está diciendo ese mensaje que tenemos que tener cuidado sobre eso. Okay? Are you guys understanding? So far, you got all here. You understand a little bit
Yeah,
more?
I understand, but I don't know what it is about.
So it's about nuclear waste.
What?
Nuclear waste.
Oh,
So, yeah, and why it's dangerous. And so sending this message here to the United Nations saying that it's bad, it's dangerous.
Pardon this interruption, at this time, I need all students that are registered for close-up. Staff, there was an email sent.
Alice, are you understanding a little bit?
Name,
Okay. Cedric, you good?
to that email.
We have to write the story of it.
Then I need
Yeah. So you want three things that you found interesting. So three things that you think are interesting about the story. So then I need 2 words that you learned and two words that you want to know more about. Good. We'll just, so make sure you're writing your words down. We'll discuss this once the videos are over.
English, French, Russian, and Spanish. There's a reasonable hope that, at least in the next couple of thousand years, one of those languages would be understood. But in the scope of hundreds of thousands,
This game, you're not ready.
of years, there's just little expectation that these languages would survive. There's not even a reasonable expectation that humans will survive. So, you need to convey the same message without language. What the study suggests is to further push the message by building a landscape that conveys danger. It could be a scene of thorns or spikes or forbidding blocks. To satiate the discoverer's curiosity, it's also suggested to add monoliths explaining the history of the site through pictographs. Also included would be images like this, engraved in stone, conveying that the substance has danger that will be passed on to humans if touched. But the difficulty of this is that it very well might not be humans exploring Earth 100,000 years from now. It could be a species that doesn't recognize the likeness of what might be a long extinct species. What some have suggested is to just let the site be forgotten, to not mark it at all, to just seal it up and leave. But having something that significant disappear isn't simple. The site in Finland is designed to not need security or oversight, but its current location is very well documented in a potentially irreversible way. With books and brains and the internet, records of the site might exist until at least the end of human civilization. To truly be forgotten, to truly be left as part of nature, so too must humans be forgotten. If you want to learn about clean energy or anything else, you should.
Alright, let's open the video. Okay? So, let's go back to our discussion questions real quick. Alright, so I'm gonna call on you guys, but I only want one important thing that you guys wrote down. Alright? So Alice, give me one important thing that you learned from this video.
If the power fails, the bomb stops working as well.
Okay. Good. Yvette? Menfi, ¿qué aprendiste del video? Sobre el video.
Sobre qué produce la energía
Okay.
y
Angel?
qué tan malo es.
Okay. Angel?
Toda la atómica, que puede ser muy peligroso para el mundo.
Okay. Pascualini?
Que las bases nucleares son muy peligrosas, porque no todos se pueden entrar.
Okay. Pascualini? Una cosa que aprendiste. Ok, regresamos speak. Bien. Una cosa que me dices.
Ok, que el internet y el sitio pudiera vivir al menos 20 años de la civilización humana.
Okay, so he's talking about the human civilization, how nuclear waste can last longer. So that's a good one. All right, Yvette, let me get one word that you learned. Yeah.
I want to.
I'm not. Okay. Good. What this one? Facility? So these are the ones that you know.
Yeah.
Physically increased. Those are the ones that you know already. Okay, these are the ones you. Curiosity. Okay, that's another one. Good. So curiosity. So she put that as one of the words that she wants to know. Jesus, one word, una palabra.
Suburban.
¿Cómo?
Suburban. O no sé cómo se dice.
I don't speak.
No la tengo, pero la vi.
¿Dónde está?
No la tengo ahí.
¿Cómo
Pero
era?
es que no sé cómo se escribe.
¿Cómo era la palabra? Dime otra vez.
Suburban. Algo así. ¿Cómo sobrevivir?
Oh,
Survival. Survival. Yeah. That's the one. All
Es que no sé
right.
cómo se
Emerson,
escribe.
una palabra que aprendiste. ¿Cómo? Silence. A ver, déjame ver.
Y yo, nuclear.
That. Tolerance. Okay.
¿Qué aprendiste?
Okay, good. All right, we're gonna discuss this more in a little bit. Now we're gonna watch the other video about Yellowstone. So remember what you want to know. All right, 3 important things you learned, 2 words that you want to learn, 2 words that are chemistry related, and what can happen if a volcano like Yellowstone erupts.
I learned about the what so what are the things that can produce energy?
Alright, acuérdense para el segundo video que lo que quieren aprender son 3 cosas importantes del video, 2 palabras que quieren aprender más sobre ellas y 2 palabras que están asociadas con esta clase. Alright, so remember, you want 3 important things that you learned from the video, 2 words that you want to learn more about, and then 2 words that are related to chemistry. Huh? Yeah. So if you've heard it before in this class, you've read it down. All right?
¿Es importante hacer notas?
Yes.
Realmente. No.
My name's Corey. I've been a Lake Trust member since I was 18 years old. Lake Trust has been...
This video is made possible by Skillshare. The first 1,000 people who follow the link down in my description will get 30% off of an annual subscription to Skillshare Premium. Geographically, the United States has to be one of the most beautiful countries in the world. From the Grand Canyon to the Rocky Mountains to the beaches on 2 of the world's oceans and beyond. The list just goes on and on. There's so many beautiful parts of the United States that the country established its own National Park Service back in 1916 in an effort to help maintain and protect them. And in total, the service is now in charge of 63 of these protected areas, and when combined together, they cover an area of 85 million square kilometers, which is roughly the same size as the entire country of Germany. One of the most famous of these U.S. national parks is Yellowstone. It's located in the northwestern corner of the state of Wyoming with some overlap into Montana and Idaho, and it covers roughly 9,000 square kilometers of land. Yellowstone is well known for its abundance of wildlife and its many geothermal features. Particularly Old Faithful, a geyser that regularly blasts water 50 full meters into the air approximately every 90 minutes. Over 4 million people visit the park to take in all of these sights every year, but Yellowstone is harboring a dangerous secret. It's located just atop a slowly ticking time bomb. The largest supervolcano, not only on the North American continent, but also anywhere on the planet right now. And it has a bit of a troubled past. You see, the Yellowstone caldera that we know today was actually formed by several titanic volcanic eruptions that took place a long, long time ago. One of them took place 2.1 million years ago, another that took place 1.3 million years ago, and the most recent taking place approximately 664,000 years ago, long before Homo sapiens had ever arisen over Africa. The last of those, that surrounds the Yellowstone Lake, ended up ejecting so much material during the blast that it left a 55 by 80 kilometer depression in the ground that we now know today as the current Yellowstone caldera. And each of these three colossal events is what is known geologically as a super eruption, meaning that on the Volcano Explosivity Index, they would all be listed as of magnitude 8 or higher, and at a minimum, at least 1,000 cubic kilometers of material was ejected during the most recent blast, which is, well, insane to comprehend, because that would basically be enough volcanic ash, lava, and other material to bury the entire state of Texas 1.5 meters deep. If
¿Sí entendieron esa parte?
Poquito.
Dice que el radio cuando va a hacer erupción del volcán ya incrementado mucho. Que era 45.000 kilómetros cuadrados, va a ser ahora 250.
we look at the geological history of Earth, we know that on average, the planet suffers from one of these supervolcanic blasts roughly once every 100,000 years. The most recent such occurrence was the New Zealand Lake Taupo volcano, which blew up approximately 26,500 years ago. But by looking at the history of the Yellowstone eruptions specifically, a disturbing pattern begins to look like it's emerging. The second most recent explosion took place about 800,000 years after the third most recent, while the most recent one happened about 636,000 years after that one. And as mentioned previously, this most recent event happened 664,000 years ago, which is 28,000 years longer than the time between these two most recent explosions. This is one of the biggest reasons why Yellowstone in particular often receives so much attention in the global press. However, experts and scientists have repeatedly assured the public that an eruption at Yellowstone anytime in the near future is exceedingly unlikely, and the volcano's current status is dormant. Based on over 30 years worth of research, the evidence gathered suggests that while, yeah, it's theoretically possible, a mega eruption isn't likely to happen any time within the next 10,000 years. Keep in mind that on the geologic timeline, it took roughly 800,000 years between event number 3 and event 2, which is 136,000 years longer than we've gone now since event 1. But that's not really any fun. If Yellowstone defied all of the odds and blew up today anyway, how bad would it actually be? Let's do some speculation. The whole Yellowstone volcanic system itself is huge. Like, it's way bigger than you probably think it is. For example, the magma chamber that lies underneath the national park today is estimated to be a single connected chamber that is 60 kilometers long, 29 kilometers wide, and 8 kilometers deep, and holds an absolutely absurd amount of molten lava. This chamber is fed by a gigantic plume of molten rock that wells up from hundreds of miles beneath the Earth's surface. And fascinatingly, as this magma rises up into the chamber and cools, the ground above will periodically rise and fall. And because of this, the elevation of ground within the Yellowstone Park will fluctuate up or down by a few inches a year. Now, before any massive eruption would take place, it would very likely be preceded by a huge amount of seismic activity. Basically a warning sign that something really bad was about to happen. Many seismologists estimate that there could be substantial earthquakes preceding any blast at Yellowstone that would last for weeks or even months beforehand as rock below gets broken up by magma as it surges further and further up towards the surface. Here, pressure would continue building and building and building and with increasing intensity until, with nowhere left to go, the magma would explode through the ground in a cataclysmic eruption, with debris getting flung as high as 24 kilometers up into the stratosphere. Shortly afterwards, the lava flows themselves would engulf the surrounding area, and anywhere inside a range of 65 kilometers from the epicenter would be in danger of becoming literally buried in lava, which is basically the entire territory of the national park itself. Beyond this immediate danger of burning, the blast would eject 1,000 cubic kilometers of material up into the sky, creating a type of umbrella cloud expanding evenly in all directions and darkening the skies over most of the North American continent. This cloud would rain down toxic volcanic ash across the entire mainland United States. Wyoming, Idaho, Colorado, Montana, and Utah will, however, experience the most significant devastation and will probably be almost completely buried with up to a meter thick of hot volcanic ash. Denver, Salt Lake City, and Boise will be severely damaged or just outright destroyed.
Entonces, si ven, was it in this class? Were we watching in this class the movie 2012?
Yeah.
Was it in this class? Okay. Remember the movie 2012? We were watching it. I don't know if you guys remember, but there was a scene with that volcano erupts.
Oh.
Remember that? See that volcano? What they were talking about was this, was Yellowstone, right? So right here it's giving us the graphic of this. It's all ash, right? And these are the cities right here that will be severely damaged. So in blue is all lava. And over here it starts expanding out, and it's gonna be even worse, right? So over here is the worst, it's expanding out, and eventually we're gonna see when I play the video, it's gonna expand out all the United States, all right? Si ven para acá está el volcán, y acá es donde va a ser más daño, pero van a ver que se va a hacer más grande ese círculo y va a llegar sobre casi todos los Estados Unidos, right?
Meanwhile, across the Midwest, Nevada, and southern Alberta, there would still be inches of ash coating everything in sight. Even the Atlantic and Pacific coasts would likely see a small dusting, although much of it would be highly dependent on the time of year and weather patterns involved.
Entonces, acá Alexis andamos preguntando que si llegaría a México.
Va todo Baja California, ¿no? Sí,
Pero no nomás es lo que ven acá, es el daño que le va a hacer a todo el planeta. Porque aunque lleguen nomás a Estados Unidos, estamos hablando de muchos lugares acá que sembramos, right? So it's going to keep on telling us that even though this is going to be the main area of damage,
¿Esa es la continuación?
we have so many areas here that we have crops, we build stuff. You know, we're a very important country, and we'd be the one to be the more severely damaged, right? But that's not just it. All right, other places in the world that depend on us are gonna suffer as well. All right, and we're gonna see that just because this volcano right here erupted, this video is gonna keep on telling us how it's gonna affect the whole world. All right, so it's not just because we see the United States is the one that takes damage. It's only going to be the United States going to be affected. It's going to be the whole world is going to suffer if something like this were to ever happen hopefully never happens in our lifetime. Pero van a ver que aunque solamente es acá en Estados Unidos donde va a ser el más daño, el video les va a enseñar como sobre todo el mundo, esto va a causar un problema.
Basically, if you're looking at this map, everything in blue would be completely wiped out. Everything in purple would be highly damaged. Everything in orange would be sort of damaged. And everything in yellow would be mildly damaged. The North American continent would take a pretty significant bruise. But the worst part of all of this would obviously be the terrible toll that it would take on human life. With a full meter of ash possibly being poured down upon you and your city, even if you are not close enough to see the volcano, it could still possibly kill not only you, but also plants, animals, and even crush buildings with the sheer weight of dense ash deposits. Even just a few inches of ash can completely ruin farmland, clog up roadways, and create serious respiratory issues for large amounts of the population. Not to mention that it would take out key infrastructure, contaminate water supplies, down power lines, prevent nearly all air travel on the entire continent, and even take out electrical transformers, which would bring America's power grid to a complete and utter halt. What could be even worse is that the ash would likely wipe out the entire Midwest's crop of corn and soybeans, and could even poison the farmland for an entire generation. This would make food production within the United States severely crippled, and America would likely have to rely on food imports from other continents in order to survive. But beyond the absolute chaos going on across North America, a volcanic eruption this big would also have a major impact on the global climate and affect everybody who lives on this planet in some way.
Entonces ahorita les va a explicar cómo el volcán puede afectar todo el mundo. Alright, so it's about to tell you how this whole eruption could damage the whole world.
You see, volcanoes can emit sulfur aerosols that are capable of reflecting sunlight back away from the Earth, which causes the climate to cool down. For example, most recently, when Mount Pinatubo erupted in the Philippines in 1991, it's estimated that it cooled the planet by an entire 1 degree for at least a few years. And that's not to mention the Great Tambora eruption, which occurred in Indonesia in 1815. That eruption, which was rated as a category 7 on the explosivity index, is believed to have cooled the planet enough to damage crops around the world, potentially even causing several severe famines in certain areas. There was even snowfall during the month of June in the eastern half of the United States that year, as it became known as the year without a summer. These eruptions, however, were relatively tiny events.
Entonces, escucharon que dijo ahí que el volcán que eruptó en Tambora, que está allá en los Filipinas, que eruptó en 1887 creo, y que cuando eruptó enfrió el planeta tanto que el siguiente año acá en Estados Unidos, en el mes de junio, andaba nevando, ¿verdad? Entonces ustedes tienen que ver que cuando erupta un volcán grande así, tapa el sol, toda la ceniza tapa el sol, y toma tiempo para que la ceniza
es porque es más
es más densa, no sé cómo digo, más gruesa.
No, es más, es como más nuclear.
So you gotta realize that when an eruption like this happens, all the ash goes all the way up in the air and it blocks the sun. Hey, it blocks the sun, right? And that's why you have situations where an eruption like that happens and the world gets colder. You know, it talks about how when the eruption in Tambora happened, the following year, the earth got colder and there was snow in June. Right? Snow in June. Can you imagine what if we had snow in June? ¿Verdad? Emerson, va a ser mejor un partido en el Clemente en el mes de junio y está nevando. Imagínate. ¿Verdad? Right? Or you're going to go play basketball with your friends We're gonna go, do something in the park, and it's snowing in the month of June. It's crazy. ¿Verdad? Imagínate eso.
Alexis quiere ir a jugar a Clemente.
A Clemente.
When compared to what a super volcanic Yellowstone eruption might look like. Although it's hard to say with any kind of certainty, scientists estimate that with the amount of material that would be ejected into the atmosphere, the planet might cool by as much as 10 full degrees for an entire decade following a cataclysmic eruption at Yellowstone. Obviously, a change in the climate that huge would cause a global catastrophe, as crops around the world would be affected, likely endangering the lives of hundreds of millions of people and doing untold amounts of damage. FEMA, the U.S. Federal Emergency Management Agency, even published a rough estimate on what it thought the total damage cost to the United States would be in the event that Yellowstone ever actually blew. In that report, they estimated that it would cause roughly $3 trillion in damages, or almost 14% of the entire United States GDP. So, yeah, Yellowstone blowing up like this would be really, really bad for everybody. But it's more than likely not gonna actually happen during any of our lifetimes, unless one of you becomes immortal. Because if you look at the frequency of the last 3 big eruptions, the odds of one happening in any given year are roughly 0.0001%, which is actually lower than the odds of civilization getting wiped out by an asteroid. So, this isn't really a problem that you have to worry too much about right now. But maybe there's another problem or challenge that you are facing right now for a big personal goal or a passion project that you've been really...
All right. Entonces el último dice que las posibilidades de que este volcán no eruptara es 0.00001% que podría pasar esto en nuestras vidas. All right?
¿Entonces que no hay posibilidad?
No hay posibilidad, pero
puede
nunca sabes.
All
All right?
sea, hay pero sí.
All right. So let's say the chances of this happening in our lifetime is 0.00001. All right? So hopefully that never happens in our lifetime. Okay? All right. So let's go back to our questions real quick. Okay. Let's start with Yadiel. What are 3? Let's do. What's one important thing that you learned from this video? A mega reaction can happen in the next 10,000 years. Que una erupción puede pasar en los próximos 10,000 años. All right, good. All right, Cedric. Hey, guys. Por favor. Is there one important thing you learned from the video? One important thing you learned from the video. Here, we'll be closer. You're understanding. No? Yes, because the park does receive millions of people, tourists annually. So even though it's dangerous, a lot of people go visit it because it's a very beautiful park. Entonces yo sé que el parque tiene mucha gente que va a visitar el parque cada año porque sí está, es un parque bien bonito.
Y también los animales se les echan a orilla.
Yes, good. Fidel, una cosa interesante que pendiente su video.
Una cosa interesante, bonita. ¿O cómo dijo?
Interesante.
Una cosa interesante.
¿Cómo?
Ya.
Dímelo. Guys.
What if? What if?
Okay, so he said the interesting characteristics of how the volcano can damage the world. Good. Else, something interesting that you found from the video.
A lot of stuff is getting wrong.
A lot of stuff can get wrong. Yes. Menfi?
What if it explodes almost all of the United States?
Good. All right. So he said if it explodes, most of the United States will be dead. All right. Now, something interesting from the video. Yes. So the eruption can damage our land. Good. All right. Angel. Hey, guys. Angel. Una palabra que aprendiste. ¿Cómo? Volcano. Okay. Emerson. One word. ¿Cómo?
You.
What, Carlos?
Deadly. Deadly, yes. Deadly. Deadly is very dangerous. It can kill you. Alright, Yvette, one word. FEMA, yes. That's one of the organizations that they talked about. Angel, please. Alright. Let me see. Gabriel, give me a word that is chemistry related. Stratosphere. Good. Who have I called on here? Jesús. Una palabra que está asociada con chemistry.
Chemistry. No sé, yo puse de...
What? ¿Esta? Element. Yes. Elements. Good. All right. Real quick. Lo importante de esto es que aprendan que todo lo que pasa en este mundo, así es el mar, el aire, la gas, el mofle de un carro cuando sale el aire del carro, las fábricas que ven que sale humo, ¿verdad? Si te echas un pedo,
Cuando el carro ya no le sirve el aceite.
no sirve aceite, una bomba, ¿verdad?
Yo me he hecho 1777.778.
Pedo, ¿verdad?
Pedo.
Pase lo que pase todo, mira, pase lo que pase, todo es parte de un elemento, ¿verdad? Que tenemos que tratar la periódica.
Son compuestos químicos.
Compuestos químicos. All right. So what we're trying to learn here is that every single thing that happens in our planet is related to an element, right? Regardless of what type of element it is, everything that you see here is element based, right? Otro ejemplo, bien rápido. ¿Por qué? ¿Alguien me puede dar una razón? ¿Alguien me puede dar una razón? ¿Por qué hay ciudades grandes? Hay ciudades grandes, ¿qué son? ¿39?
38.
¿Por qué hay ciudades grandes que están al lado de volcanes? ¿Por qué? Why is there large cities next to volcanoes?
¿Por qué?
Porque... What?
Ay, sí sabía, pero se me olvidó.
Anybody know? We got cities in Japan, en Japón, que están al lado de volcanes. La Ciudad de México,
Tiene un
¿por
volcán.
qué un volcán ahí? ¿Por qué? Why?
Porque pueden extraer más
¿Más bien?
suministros.
¿Cómo?
¿Cómo se dice?
Suministro.
Ajá, eso.
Ministro.
Puede ser.
Okay, that's a good reason.
Tiene beneficios.
Why?
Tiene beneficios.
Copió.
Beneficios de qué?
Para como energía.
Ajá, yeah.
Dije suministros.
Hacen las
Dice suministros, sí.
Porque el suelo es fértil.
Ajá. El suelo es fértil because we have fertile soil, like Angel said. Hey, snuff! Because we have fertile soil, and when a volcano erupts, cuando un volcán erupta, toda esa lava que ven son minerales que salen por debajo de la tierra Y todo eso, aunque los mate, es algo que va a hacer qué?
Va a ser fértil.
Va a ser fértil. Y por eso ven ciudades como la Ciudad de México, ciudades de Japón, que hay mucha naturaleza. Mira, en el parque donde está ese volcán de Yellowstone, está grandísimo ese parque y ya tiene muchos árboles, mucho pasto, mucha naturaleza. Porque sobre los años, cuando un volcán erupta, todos sus minerales hacen árboles, hacen pasto, hacen plantas, hacen comida. Right? All those minerals that erupt from volcanoes, those end up turning into trees, they end up turning into grass, into fertile soil that we can use to farm. Right? So even though it's deadly, it's healthy for, other purposes. All right. You guys make sure to turn these in. You guys got a couple of minutes.